In this video, we're going to take a look at some examples solving non-right triangles using the law of cosines. So here's a situation in this example where we want to solve a triangle with side length A equal to 2, side length B equal to 3, and angle C equals 40 degrees. In this case, we have two side lengths, A and B, and we have the angle 40 degrees that's between them, the included angle. And so because we do not have a side length and angle that are opposite each other, this is a good indication that the law of cosines should be used to solve this particular triangle. Because I know side length A and B, one of the things that we should find right away is the side length C. So we're going to take the version of the law of cosines that is solved for C squared. And that's equal to A squared plus B squared minus 2AB cosine of angle C. We can substitute all of our given values into this. It's going to be 2 squared plus 3 squared minus 2 times 2 times 3 times the cosine of 40 degrees. We have 4 squared plus 4 plus 9, which is 13, minus 2 times 2 times 3, which is 12, cosine of 40 degrees. At this point, we really have no choice but to put this into a calculator. And when we do, we see that C squared is approximately 3.81. And solving this for C, we take the square root. And we get that C is approximately 1.95. So the length of side C is just a bit smaller than 2. Right. We now know all three of our side lengths, and we know angle C, and so then we have to find angle A and B. To find angle A, we can use the version of the law of cosines that's solved for cosine of A. So this will be B squared plus C squared minus A squared, all over 2BC. We can substitute in the values that we've been given. So B is equal to 3. C is the value we just found, 1.95. And A is 2. And this will be over 2 times 3 times 1.95. Right. We can enter this into a calculator and see that the cosine of A is equal to approximately 0.7524. Once we know the cosine of angle A, we can find the angle A itself by looking at the inverse cosine of this value. So the inverse cosine of 0.7524 is approximately 41.2 degrees. This will be our angle A. Note that because we're using the inverse cosine here, there is only one value between 0 and 180 degrees with this particular cosine. So unlike the law of sines, there's only going to be one triangle here to find, and it will have A equal 41.2 degrees. Once we have angle A, we can find the remaining angle, which is angle B, by subtracting the two known angles from 180 degrees. So in this case, 180 minus 40 minus 41.2, and this gives 98.8 degrees. And this is our last angle and our last piece of information for this particular triangle. In our next example, we're asked to solve the triangle with three given side lengths, A equal to 3, B equal to 4, and C equal to 6. Because we know the three side lengths here and none of the angles, we're going to need to use the law of cosines. And in particular, we're going to have to use the versions that are solved for the cosine of our angles. So for example, to find angle A, we're first going to find the cosine of angle A and then use the inverse cosine function. According to the law of cosines, this is going to be B squared plus C squared minus A squared all over 2 times B times C. We can compute all of this out. The numerator will be 43. Our denominator will be 8 times 6, which is 48. And so cosine of A is 43 over 48. And therefore A will be the inverse cosine of 43/48, which is approximately 26.38 degrees. To find angle B, we can go through the same process. The cosine of B will be A squared plus C squared minus B squared all over 2 times A times C. Our numerator here is now, looks like 29, and our denominator is 36. And so angle B will be the inverse cosine of 29 over 36, which is approximately 36.34 degrees. To find angle C, we could do the same process again. We could first find cosine of C, and then take the inverse cosine function of that. Or, because we know the three angles need to add to 180 degrees, and we feel confident about our two angles so far, we could simply subtract these two angles from 180 degrees to find that C will be 117.28 degrees. And since we were given the three side lengths originally, and we have the three angles, we've now completely solved this particular triangle.